Now come to the next question, my dear children, that is question number 11. Show that the relation R in the set A of points in a plane given by R is equal set of all ordered pairs P comma Q such that distance of the point P from the origin is same as the distance of the point Q from the origin is an equivalence relation. Further, show that the set of all points related to a point P is not equal to order pair 0, 0 is the circle passing through P with origin as center. Now come to the solution. In the question there are two parts. First one is we have to show that given relation is an equivalence relation, and the rest of the part is the second part. Okay, my dear children. Now given set, what is the given set? Set A of points in a plane, that is a given set. Now given relation, what is the given relation? R is equal to set of all ordered pairs P comma Q such that distance of the point P from the origin is same as the distance of the point Q from the origin. Okay, my dear children. What is the first relation? Reflexive relation. We have to show that the given relation is an equivalence relation. So first we are proving that given relation is a reflexive relation. Okay. Let us take a point P be any point in the plane. Means P belongs to A. Now the distance of the point P from the origin is same as the distance of the point P from the origin. It means in the given relation we wrote the point P in the place of P and Q only. We rewrite the given relation like this, given statement like this. If we have to, now we have to check whether this statement is true or false. Yes, it is a true statement, right? This implies ordered pair P comma P belongs to R. It means the points P and P satisfy the given relation. Therefore, R is said to be a reflexive relation. Now come to the next relation, that is symmetric. To show that this relation is symmetric, let us take 2 points from the set A, namely P and Q, and the 2 points are satisfying the given relation. We have to assume that like this. Now, P comma B, Q ordered by P comma Q belongs to R. What is meant by this one? That means the distance of the point P from the origin is same as the distance of the point Q from the origin, right? Then the distance of the point Q from the origin is same as the distance of the point P from the origin. Just we have written the relation. In that relation, just we interchange the point P and Q. Okay, my dear child. Then we get this statement. Now we have to check whether this statement is true or false. After rewriting the given relation by interchanging the places P and Q, we get this statement. Now we have to check whether this statement is true or false. Is it a true statement or false statement? Is a true statement. This implies we can write it as ordered pair Q comma P belongs to R. What is meant by this one? The relation R is symmetric, right? Now the third relation, that is a transitive relation. To show that the given relation is transitive relation, you know that we have to take two link ordered pairs. So we have assumed that ordered pair P comma Q comma ordered pair Q comma S belongs to R. These two are link ordered pair. Just observe these ordered pairs. Okay, my dear children. Now ordered pair P comma Q belongs to R. Okay, what is meant by ordered pair P comma Q belongs to R? It is the distance of the point P from the origin is same as the distance of the point Q from the origin. Let us consider this statement as 1. Okay. Similarly, ordered pair Q comma S, ordered pair Q comma S belongs to R. We assumed here. What is meant by this one? Distance of the point Q from the origin is same as the distance of the point S from the origin. Let us consider this statement as 2. If you observe from the statements 1 and 2, we get distance of the point P from the origin is same as the distance of the point S from the origin. Okay, my teacher, we get this statement from 1 and 2. What is meant by this one? This implies ordered pair P comma S belongs to R. Okay, my dear children. Therefore, the points P and S are also satisfying the given relation. Okay, my dear children. Therefore, R is said to be transitive. Right. Therefore, the relation R is said to be an equivalence relation because it is satisfying the reflexive relation definition, symmetric relation definition, and also transitive relation definition. Therefore, R is an equivalence relation. This is the first part of the question. Now come to the second part of the question. So, the set of all points related to P is not equal to ordered pair 0, 0 will be those points whose distance from the origin is the same as the distance of the point P from the origin. Okay, my children. Hence, this set of points forms a circle which passes through point P with the origin as center. Okay, my dear children. This is the second part of the question. Right. Now come to question number 12. What is the question number 12? Show that the relation R defined in set A of all triangles. Okay, my dear children. Here set is set of all triangles. The relation R is defined as R is equal set of all ordered pairs T1 comma T2 such that T1 is similar to T2. This is a relation between any two triangles in the plane. Now we have to show that this relation is an equivalence relation. Okay, my children, this is the first part of the question. Consider three right angle triangles. Right. T1 with sides 3, 4, 5, T2 with sides 5, 12, 13 and T3 with sides 6, 8, 10. These are the three triangles T1, T2, T3. Their sides are given like that. Which triangles among T1, T2 and T3 are related? Okay, this is the second part of the question. Okay, my dear children. Now come to the solution. What is the given set? Given set A is the set of all triangles. What is the given relation? The given relation R is equal set of all ordered pairs T1 comma T2 such that T1 is similar to T2. This is a given relation. Okay, my dear children, we have to show that this relation is equivalence relation. So first of all, we prove that it is a reflexive relation. So to show that this is a reflexive relation, we have to choose only one element from the set A. That is T1 is selected. T1 is chosen from the set A. Now T1 is similar to T2. We rewrite the given relation by taking the values T1, T2 as T1 and T1 only. Then you get this new statement. Now we have to check whether this new statement is true or false. By rewriting the given relation, by interchanging T1 and T2, we write T1 only. Then we get this statement. Now we have to check whether statement is true or false. Yes. Is it a true statement or false? It is a true statement. Then what can you write this one? This implies that ordered pair T1 comma T1 belongs to R. Okay, my dear children. That means the triangles T1 and T1 are satisfying the given relation. Then we can say that R is reflexive. Right. Now, what is the second relation? That is a symmetric relation. To prove that the relation is a symmetric relation, we have to select any two elements from the given set. So we have selected two elements, namely T1, T2 belongs to A. And we have to assume that the two elements are satisfying the given relation. We assume like this, ordered pair T1 comma T2 belongs to R. It means triangle T1 and triangle T2 are satisfying the given relation. We have to assume like that. Okay, my dear children. Now, ordered pair T1 comma T2 belongs to R. What is meant by this one? T1, the triangle T1 is similar to triangle T2. Okay, my dear children. This is a given relation. According to the given relation, we have to write this statement. From this statement, can we write this statement or not? See this statement. T2 is similar to T1. From this statement, can we write this statement or not? Yes, we can write. So by seeing this statement, can we write this one? Ordered by T1 comma T ordered by T2 comma T1 belongs to R. Okay, now the relation R is said to be symmetric. First we have chosen order pair T1 comma T2 belongs to R. Finally we have proved that order pair T2 comma T1 belongs to R. It means R is said to be symmetric, right? Now come to the next relation, that is transitive relation. To prove the given relation is transitive, we have to select any three elements from the given set. What is the given set here? A. So from the given set, we have to select three elements. We have selected three elements, namely T1, T2 and T3 from the set A. We have selected like this. And also we have to assume that T1, T2, T3 are satisfying this relation like this. Order pair T1 comma T2 belongs to R and order pair T2 comma T3 belongs to R. We have to assume like that. If you observe these two order pairs, what are these are two order pairs called? Link order pairs. Do you remember this one? Okay, my dear children. Now, order pair T1 comma T2 belongs to R. What is meant by this one? According to the relation, a triangle T1 is similar to triangle T2. This is considered as T1 statement 1. Similarly, ordered pair T2 comma T3 belongs to R. We assumed here. So what is meant by ordered pair T2 comma T3 belongs to R? T2 is similar to T3. It means triangle T2 is similar to triangle T3. We assume this is a second statement. From the statements 1 and 2, we can get, so T1 is similar to T2 and T2 is similar to T3. That implies we get here T1 is similar to T3. Isn't it or not? Yes. This implies ordered pair T1 comma T3 belongs to R. It means triangle T1 and T3 are satisfying the given relation. Therefore, R is said to be a transitive relation. So here R is reflexive, R is symmetric and R is transitive. Hence we can say that R is an equivalence relation. Okay, my dear children. Now this is the first part of the question. This was proved. Now come to the second part of the question. What is given here? The triangle T1 with the sides 3, 4, 5 and the triangle T2 with the sides 5, 12, 13 and the triangle 3, 3 with the sides 6, 8, 10. Now let us find the ratios of corresponding sides of the triangles T1, T2 and T3 by taking the triangles in pairs. Okay, my dear children. Now we are finding the ratios of corresponding sides of the triangles T1, T2, T3. Okay, here I have taken the triangles T1 and T2. Then this is the ratio of corresponding sides 3 by 5, 4 by 12, 5 by 13. But these three values are not equal. So this is the result 3. Consider this one is result 3. Similarly, I have taken triangle T2 and T3 and we have taken the corresponding sides ratio 5 by 6, 12 by 8, 13 by 10. These three are also not equal to each other. So I consider this result as 4. Now I have taken the triangle T1 and T3, that is 3 by 6, 4 by 8, 5 by 10. If you observe here, the three ratios are equal. Okay, my children, I consider this result as 5, right? So from the result 5, we get T1 is similar to T3 because the two triangles T1, T3 are similar to each other because the corresponding ratios of the sides are same. Hence, the triangle T1 is related to triangle T3. Okay, my dear children, right?